Great. Hello, everyone. I have decided to pull together this recording to help you with assignment number one. So I've posted a few things into Quarkus, and I'll post this presentation. Obviously, I'll post the slides as well. And in addition to that, just another Excel document that will start you on your way in terms of your interaction table as well as your consequence table. So that should give you all the information that you need in order to do the assignment. So I am going to share my screen and I am going to go here, PowerPoint slides. There we go. And here we go. So this is a review that I pulled together for assignment number one. And just as a bit of a introduction, these are actually the links to the ICLEI guidebook and worksheet. So this is the first link here. You can go to that and then you'll find in PDF format the guide and then the workbook itself. So feel free to take a look at that. You don't have to. Remember, I had outlined the sheets in the lecture last Tuesday, and we'll go through a couple of those again in this presentation. Oops. So just as a reminder, in terms of risk management and the Arnell book, essentially what we're focusing on in this assignment is really the beginnings of the risk assessment process. And then we'll be migrating and advancing into the risks themselves and putting forward some adaptation options to deal with those risks in assignment two and in the final exam. So just as a reminder, that risk is an outcome of the frequency of the climate variable. So when heavy rain occurs times the consequence, when bad things happen to infrastructure assets in energy, in transportation, and others. And more importantly, taking vulnerability and adaptive capacity into account, the likelihood of the climate impact actually occurring. So the example that I had used in class was the GO train that ran along the Bala subdivision in the Lower Don and along the Richmond Hill corridor, Richmond Hill line, and at the level of below the 2-year floodplain, that train was flooded in 1981 and again in July 8th, 2013. So the likelihood of that train being flooded again is actually very low based on the changes that Metrolinx put in place in terms of improved monitoring, improved reporting on water levels, improved observation through closed circuit television of the corridor, and also advanced for weather forecasting and operational changes, or changes rather in the operational protocols by the conductors for that not to happen again. And so I would go to bed at night, not that it was my responsibility, but I was certainly obviously interested and connected to flood risk in the Lower Don when I worked at Metrolinx. Would not go to sleep worried that there would be the next day you would see a flooded train. You would see or could see a flooded track or overtopping of track, but it was pretty clear that we would no longer put a train in harm's way, to describe it that way, in the future. So that's where I make a distinction between frequency of the climate variable and likelihood of the impact actually occurring. So we had talked earlier about the risk management, risk assessment process, the 5 steps that are articulated in the ICLEI methodology, as well as the PIVC protocol: screening and scoping, risk assessment, selection of adaptation measures, implementation, monitoring, and reporting, really the building blocks of doing risk assessment and risk management. And we're really trying to focus on the first two of these, at least in assignment number one. And just as a reminder, as it ties in with the ISO 31000 risk management framework, again, you can go through establishing the context, risk identification, risk analysis, and that's about as far as we're going to take it in assignment number one. And here is another interpretation for municipalities, a very early iteration of the ICLEI BARC tool, one that was developed, I think it was 2007 by Jim Bruce, and was a former assistant deputy minister at Environment Canada, a municipal climate risk tool. Again, it's consistent with the methodologies that we've looked at earlier. So looking at ICLEI BARC, and again, if you go to the link that I had shown you on slide number 2, you can find the guide and as well as find the worksheets. And this follows the same 5-step process: initiate research, slightly different terminology, plan, implementation, and monitoring and review. And this is where I drew from both the PyVC version of this in terms of its own worksheets, and then the ICLEI worksheets, the steps and the questions and the asks in the 10 to 15 page assignment that you're going to be, or report rather, that you're going to be submitting as your assignment one, not taking tables into account. You can go through that. Milestone number 1, identify stakeholders, building a team, identifying a champion, looking at or taking rather a first look at climate change impacts and existing adaptation actions, and then moving to milestone number 2, initiate research, refine impacts, understand vulnerability, and the like. So as I said, the ICLEI BARC methodology is consistent with the PyVC protocol, Public Infrastructure Engineering Vulnerability Committee, or PyVC as we like to call it. And just going through again and zeroing in on the worksheets for ICLEI, stakeholder identification, who are we trying to visualize in terms of being part of this exercise, and the fact that you've been hired by the city of Metropolis, and you've been tasked to pull together a report that will eventually be submitted to the federal government in search of funding for infrastructure projects to strengthen the resilience of your energy and your transportation systems in Metropolis. And if you go back and you take a look at the slides from last Tuesday, as well as this one again, which I've reproduced, it's in red the possible stakeholders. These are the examples, both internal and external, the stakeholders that you can draw from. They're not identical, but you can draw from in terms of how they may apply to the city of Metropolis and assignment 1 in the case study. So there's a lot of information in the case study. It's really rich in information, if not dense in information, but it's quite a creative and interesting narrative in terms of giving you full flavor of the diversity of the region and its relationship in the past, primarily, at least for this assignment, in terms of how it's been vulnerable to extreme weather conditions as it applies to the region as a whole and to the key assets that we're looking at. So who are the stakeholders? And you can see this on this table, other municipal departments, that would be internal, city manager, city operations contractors, and then possibly utilities is a bit both internal, external, but then others that may be more external stakeholders. So whether or not from the agricultural community, First Nations, and on the other column, non-governmental organizations, community groups, and the like. So again, that's just a generic list from ICLEI. Take a look at the case study for Metropolis, and I'm curious to see what you come up with. And then in terms of building a team, this is another sheet or worksheet from ICLEI. There on the right is the department, agriculture, communications, and the like, and then the broader groups, again, looking more externally in terms of those that you may want to engage in this kind of an exercise. And here they are. Again, I just thought I would just draw those forward. And you can see both on the top, the representatives from within the city, primarily. Although, you might say, well, port and harbor management, is that part of the city? Well, probably, most likely. And then the groups across the community that you may want to engage. And there may be others that you want to fine tune, considering the fact that we're looking at transportation infrastructure as well as energy infrastructure. So the assignment, very straightforward in terms of it being grounded in a real world, real case situation, trying to align it with the federal budget from 2025, as well as historically how the federal government has provided funding for infrastructure projects. And looking for you to, again, develop a report leading to a proposal to the federal government where you're seeking up to $5 billion in order to support the construction or refurbishment of legacy assets or new infrastructure projects. So when you go through this, and again, I'm just reiterating what's in the assignment itself, the assessment framework. I've expanded it from 5 to 7 different steps under Figure 2 for the PIVC protocol process. And we also talk about the importance of differentiating between simplistic relationships in terms of looking at cause and effect in terms of climate change impacts and adaptation responses, whether or not these are simple, whether or not these are complicated, or whether or not risk is actually complex. And I tend to lean more towards the complicated and the complex, but that's really, at the end of the day, up to you to make that decision as well. And certainly every situation is unique. Some may be simple, some may be complicated, and some may be complex. So the exercise itself, we've laid this out in terms of 3 steps. And whereas in the past, we were much more in terms of just answer these questions, short answer questions, I thought I would massage the questions, frame it more within a report context. So I'm really looking at this report being a introduction, and then step 1, step 2, step 3, however you want to give headings to those steps, and then a conclusion, and wrap that up with your tables, 15 pages plus your tables, or less, as the case may be. So just reiterating what I presented in the lecture and what I'd said earlier, $50 billion in the federal budget, and they're prepared to spend that over the next 5 years. New capital projects costing at least 10 million or more are eligible for funding, up to a total for a combination of projects of $5 billion. And that the National Federation of Municipalities, or in the Canadian context, the Federation of Municipalities, FCM, Federation of Canadian Municipalities, has endorsed the program. So you've been asked essentially to consider and recognize how Metropolis has been impacted by extreme weather events in the past. And while we're not yet there, at least for assignment 1, too worried about the future and how that climate is going to change, I'm really trying to take you step by step without moving too quickly to look at the past, understand interactions between assets and extreme weather, and come to terms with that in terms of what the potential consequences are when severe weather or conditions are quite bad or lead to bad outcomes in terms of infrastructure condition, performance, service delivery, safety, and the like. So, as a subject matter expert on climate resilience employed by the city metropolis, you've been tasked by the manager and director to provide a report outlining infrastructure recommendations. So, that backgrounder, I can't emphasize enough, is really your encyclopedia for you to draw from that provides virtually all, but perhaps some supplementary material in the lectures, or I may introduce some additional material along the way, is all that you really need in terms of doing the assignments leading up to the final exam. And I do want to stress, because we're doing this in somewhat of an iterative way and collective way, that there is no right or wrong answers. And that's why I didn't want to necessarily wed ourselves to what we had done in previous years and give us the opportunity, all 55 of us and myself and our TA, to be able to look at this with a new and improved critical set of eyes and to be able to say, okay, well, wait a second, how about this? How about that? Geez, and looking back in previous years, you hadn't thought of that. And in fact, as we get into this and I reveal a little bit more and provide some direction in terms of how to do the assignment, you'll see that I have broadened it somewhat based on the maturing of my own thinking and conversations with Dr. McClellan as well to arrive at this point. Okay, so this is really what we're trying to focus on in assignment number 1. Scope. Who are your stakeholders? How do we identify our assets? What are the climate issues in the past that we got to be concerned about? Should we do a site visit? And if we were to do one, what 3 sites would we visit? What is our interactions between our assets and our climate hazards? And then what are the consequences? And up front, I will tell you that although it's not the final version of the climate hazards that I will share with you in assignment number 2, you'll note that in the addendum that I posted earlier this weekend on Friday, that I've already given you the climate hazards, at least the base of that or foundation. If you want to add others, and some of you are eager beavers, please feel free to do so. In fact, now that I think of it, I forgot there is one going back through the case study in terms of the different climate parameters that are mentioned. There is at least one that's missing in the variables or the climate hazards that we look at. So there's a bit of a challenge for some of you is to find that one and propose that should be added to our list of climate hazards. Okay, so as I said, figure 3 outlines a hierarchy of risk types differentiating between simple, complicated, or complex. And that tool or that hierarchy, not that you're going to be asked explicitly to illustrate your understanding of that, but as we get into the assignment, particularly in terms of cumulative, compounding, and cascading effects, that's when you begin to see, wait a second, these outcomes are actually quite complicated, quite complex in terms of causation and effects and outcomes, and what are the appropriate adaptation responses. So the questions, what are the main objectives of your report? That's again embedded in the assignment. Outlines that in terms of this is what you are expected to be delivering in terms of this federal program. And then looking at the case study and metropolis narrative, how has the region's infrastructure, economy, ecology, and social systems been impacted by extreme weather in the past? Identify the key internal stakeholders involved and explain why you would choose them. Identify the key external stakeholders and again, explain why. And then in the second section, identify the primary infrastructure assets. Now, I'm going to say, and I'll illustrate this in the material that I posted earlier in the weekend. When I went back over the original documentation back from, I think it was 1999, that was provided on asset classes, group elements, and individual elements. And then I took another look at the real world case of looking at infrastructure assets and drawing from literally global leaders in infrastructure assets or transit infrastructure assets. I realized that there was no consistency in terms of what had been done, at least in two of the projects for the Ontario line that I had been involved in. And I thought to myself, whoa, Dr. Chiotti, that might have been a bit optimistic on your part, ambitious on your part to expect students to be able to come up with a differentiated list by asset classes, group elements, and individual elements, when in fact your international subject matter experts weren't able to do that or didn't do that as part of the real world exercise. So I'm stepping back from that, and I'm basically we're just going to look at asset classes, and that is, transportation, energy. We're looking at the bridge, and then it's really the group elements, which means, okay, let's break down that bridge into smaller parts, or break down transit into smaller parts, or break down the power plant into smaller parts, and transmission and distribution lines in smaller parts and the like. So then, based on historical experience and geography, what climate hazard should be considered in this assessment. And boy, oh boy, the narrative on Metropolis really gives you a lot of diversity and flavor in terms of what the historical experience has been like. And then what time horizon should be considered in the assessment in terms of the future. And hopefully we'll touch on that, if not this Tuesday, certainly the following Tuesday, leading up to the deadline for submitting the assignment. But typically, we tend to look at the 2050s, possibly the 2080s. And when you're thinking of that, think about the assets themselves and the life cycle of those assets. And a lot of that information is already provided in the case study itself. And then step 3, the early portion or part 1 of doing the risk assessment, proposed 3 locations assets where site visit is warranted and explain why. And honestly, there's no right or wrong here, but in my head, I'm thinking of certainly 2 that would be warranted. And what that third one is, I can think of 3 or 4 examples where if I had to pick one, any of those would be justified. And then, of course, prepare and populate an interaction table between assets. And again, I'm emphasizing, let's just worry about classes and elements. Let's not worry about things in between. Just look at applying a yes or no response to interactions, or essentially an X or nothing. And I'll show you that on the proposed table. And then prepare a consequence table and estimate the severity of asset damage and failure using the PIVC scoring method from 0 to 7, or essentially 1 to 7. If 0 is essentially there's 0 impact. And I had suggested, because this is embedded in the PIVC protocol, they actually have about 7 different subcategories or criteria to think about, and sort of put them in a box, shake it all up, think about how your transit infrastructure, your bridge, or your power plant will be impacted by a climate hazard, and then come up with a score. And that would be based on one of 7 different criteria. And I had proposed of what we had applied to the Ontario line, and this has been applied to municipalities and county infrastructure. It's been applied to First Nations communities, essentially differentiating between asset performance, so the condition of the asset, the level of service delivery that asset or the level of service is dependent upon that asset. So if there's a problem uh, with the train. So looking back, if we don't put the train at risk in the water, then the asset itself isn't going to be impacted. But if we hold that train back and we don't want to run the train because the track is overtopped and we can't send the train down the track, well, then that's going to affect the level of service. So no impact on there is impact on the track. There's no impact on the train. There's no safety issue for people, but the level of service is going to be compromised. So I'm thinking, and again, I'll show you the example where level of service delivery and safety should be part of your thought process, but that just might be a little bit too much to ask at this stage of the game without providing more guidance and more direction. So I'm leaning towards just focusing on asset performance. Then based on consequence and scores, what assets would you highlight that are of initial concern? So going back over the assignment, again, it's very rich and detailed in information. A lot of the uh, information that is required to answer these questions and in the next assignment and the final exam are there. It's all buried in the creative narrative. And hit just for an example, going back over the task to identify assets. Oh my, highlighted in red. What do we have there for the bridge? Infrastructure components, road surface, bridge deck, expansion joints, piers and abutments. Um, the bridge deck itself, although that's mentioned earlier, and this is looking at the clearance of the bridge deck in terms of I believe it's the soffit, which is the underlying portion of the bridge, and then a nice addition looking at transit LRT tracks and the overhead catenary system. And there may be a few other things related to transit that you may want to add to the mix as well, but I'll let you give that some thought and perhaps come up with something. And as we then move through the assignment and we start shifting our attention away from transportation assets to energy assets, lo and behold, what do we have there? Engineering specificities of the energy system. So the generating station, the step-up transformers, transmission lines, transmission towers, step-down transformer, utility poles. And the one I just highlighted in black, just simply because we never did include it in previous years. And honestly, I'm not an energy expert. And as I'm looking at this in terms of, sub-transmission to a customer, well, who might that large customer be that would require the voltage as stipulated there under green after the substation step-down transformer? I really don't know what that might represent. Is it an auto plant? Is it a aluminum factory? Maybe something like that that would require that kind of uh, transmission of electricity, or for that matter, the transmission customer is that, meaning you're generating the power and you're selling it to Hydro One or Quebec Hydro. Is there's a difference between the company generating the power and the company distributing and transmitting the power. So that one wasn't included in the original list, and I just said, okay, there's sub-transmission to customer, although it's there in that table, not necessarily one we got to worry about in our list of assets. So I would read all the way up to about this point and the red line. The rest of it is really then starts to translate more to assignment 2 and looking into the future in terms of probabilities, in terms of specific climate variables and how they may change in the future. And I don't want you to get confused by that at this stage of the game. Focus more on the rich narrative that describes the relationship between climate hazards in the past and specific energy and transportation assets. Okay, so this is where I've added some additional material, and this is Addendum 1 that I had posted on the weekend or on Friday. And this is directly from the ASTM Uniformat 2 classification system. And I just included it there. I know that it has online in the version I had, although this says 2015 as a bit of an update. I have it from 1999, and it's for buildings. And that's great if you're dealing only with buildings, but what about bridges and transit and energy? And I know based online that there is the comparable classification guidance document for rail and transit, I believe. But again, all of these things, and welcome to the real world, come at a price. And some are available online with no charge, and others you got to put up big dollars. And even working in the private sector, I was scrambling trying to find who within the company actually had access to these different standards, is because these standards are often tied to an individual license, meaning I buy it, I pay for it, I get to use it, but I'm not legally able to share it with colleagues. It's as a single license. I might have a group license, and if that's the case, I might be able to share it with 10 people, and that's at an additional fee. So these are the things and the quirks that really challenge the whole teaching process. But I wanted to place this forward in terms of here's an example, major group elements for a building. So instead of calling it building per se, it's the substructure, the shell, the interiors, the services, equipment and furnishings, special construction and demolition, whatever the heck that is, under level 1 group elements or major group elements. And then under level 2, if we just look at the shell, for example, under B, the group elements are superstructure, exterior enclosure, roofing. And then when we get to the individual elements, that then becomes okay. Now within the superstructure, we've got a floor construction, we've got roof construction, we have exterior walls, we have exterior windows, we have exterior doors, we have roof coverings, we have roof openings for roofing. And you can appreciate just how complex this is going to get. And I'll use the term complex is because, as you start unbundling the individual assets, boy, it really, really starts to get long and involved. In terms of looking at consequence scoring and severity scoring, I've tweaked what was essentially from the PIVC protocol, and it's listed in assignment 1 at the tail end of the Metropolis case study. A variant of that for asset conditions. So if you look at the score from 0 to 7, and you check these terms in terms of very low to extreme frequent or continuous loss of asset, that's very comparable to what's in the PIVC, right? And then I decided, given a choice of illuminating you in terms of health and safety or levels of service, boy, oh boy, the level of service now, isn't that a challenging one to get your head around? And it's really different from asset owner to asset owner, company to company, depending upon their risk tolerance, whether or not they put a dollar value here or there, even in terms of health and safety. And if you remember when we were chatting in the lecture, I was explaining that we were really drawing from other examples, and there seemed to be more of 1 to 5 in terms of examples rather than 1 to 7. And so we had a bit of gaps. So here, looking at safety, 1 or few injuries is 1, multiple long-term, multiple fatalities is the number 7. And then we had blanks for 3 and we had blanks for 5. So not to say that subject matter experts couldn't select a 3 or select a 5, but we were really struggling with trying to find detailed terminology to put in there to describe those severity levels. And it differs from company to company. So when I worked at Metrolinx, one fatality was considered unacceptable and a score of 7. And in other places, I've seen hundreds of fatalities as being the highest score. So it really depends upon your perspective, and everything is subjective. So this is just an example using the ASTM uh, method, and as it was applied to an actual transit project. So I want to be very clear. I have altered these numbers somewhat than the real world case. So that being said, let me just get my little picture here out of the way. So we have stations, structural, again, I'm not worried about that, individual elements, and we've grouped these just for this example, because you would probably not just have this list, but if you're going to break it down into individual elements, you would actually then break this down, not just one, but 5 of these. And you begin to appreciate just, wow, how long and involved doing a risk assessment really is. So bundling all of those individual elements into stations, subject matter experts such as yourself and the real ones would then look at 1, 2, 3, 4, 5, 6, 7 climate hazards: hot temperatures, cold temperatures, freeze thaw cycles, heavy rain, heavy snow, freezing rain, high winds. Actually, I think it's freeze thaw is the one that we haven't used elsewhere, but I'll go back and check. We may want to add that to our list of hazards. And this gives you an example of what it actually translates in terms of simple language, in terms of what is the impact of hot temperatures on stations, degradation to the outer envelope materials due to hot temperature. Okay, straightforward. Cold temperatures, degradation to outer envelope due to condensation as temperatures cool. So that implies that it's not that they're necessarily exposed externally, but perhaps underground or in other areas, protected areas, there is condensation that builds up when you have those lower temperatures that occur. Freeze thaw is going to be damages to foundations and walls. You go through this for heavy rain, heavy snow, freezing rain. High winds, obviously, damages to roof and to canopies. And so you can actually come up with then scores between 1 and 7 or 0 and 7. And I've come up with these values because I think they were realistic in terms of what you might score in a real world case, and then do the same for service delivery, noting that if there is a 0 score, it's because there was no real interaction there in terms of service delivery. Yes, for physical condition, yes, for safety, but not for service delivery. So again, you can look at this if you wish and see how that plays out in terms of scores. And on the safety, given the fact that I just showed you that scale earlier. And in fact, let me see here. No, we didn't have the 3, we didn't have the 5, and so what we have here is our 2s and 4s in terms of the safety scores. The thing that I want to emphasize here is that whether or not it's for physical condition, whether or not it's for service delivery, or whether or not it's for safety, what we've done, or what you could do, not that I'm asking you to do this in the assignment, but in the real world case, you would actually come up with a total score. So column F, column H, column J, what does that equal? 2, 4 is 6, 2 is 2, 4, 2, and 4 is 10, etc. And I realized as I was pulling this together, this is a risk of the trade. I made an error. So in fact, not that it matters in terms of the assignment, because this was just used as an example, but I actually miscalculated my coal temperatures, I think for safety or for service delivery, so that I have a total score of 4, I think, but a maximum score of 2. So in any event, there are errors that you can make, and I think I've corrected it here. We do have a total score of 2 and a maximum score of 2. So the idea of the maximum score is that given the 3 categories, which one has the highest score, and that's the one that you bring forward. So in this case, it's a 4 under safety. It's a 2 under physical condition. It's a 4 for both physical condition and safety. It happens to be a 3 for condition and service delivery. The next one happens to be under physical condition for snow loads on roofs, has a score 5 and a score 4 for service delivery and safety. So the 6 comes forward, and again for the others, 4 and a 4. So I thought I would just highlight how looking at an individual criteria of physical condition as opposed to all 3 criteria might alter the actual consequence values. So just looking at stations, that example of the previous page, I just brought all of those maximum scores compared to, oh, sorry, I looked at the physical scores, comparing it with the safety scores, and you can eyeball that here. But over here, this is how they, oh, sorry, I was looking at all 3 criteria. I stand corrected. So I was looking at the maximum scores versus the physical scores and how they might change. And that's what we came up with. So there are some little subtle differences in terms of some of the scoring, and that'll have a bearing in terms of adding this to your probability and likelihood, and that'll give you your risk score. So there's a difference between 2 and a 4. 2 and a 2 is the same. 4 and 4, 3 and 3, 6 and 6. But then again, 2 and 4, 3 and 4. So I'm just giving you an illustration that the numbers can actually differ depending upon the criteria that you want to take into account when you're calculating your consequence scores. Okay, so this is a little bit of help. I'm compromising between those and respecting those who have already done a lot of the work. And kudos on you, and I'm keen to see what you come up with. But I'm going to give you a very, very baby step help, and just differentiating between what I would call asset class and then individual elements. And you can uh, visualize that you're essentially looking at transportation, and that's going to be likely the bridge focus. There's also the LRT, and then there's also some other non-transit or LRT assets that are listed in the case study. And then on electricity, both generation and transmission. And I've given examples from each. So road surface for the bridge, the LRT, light rapid transit for the transit, generating plant for electricity generation, transmission towers for electricity transmission, and then a new variable, which we didn't use last year, although the previous years, it did come up in discussions, both as the answers in assignment number 3 and the final exam. So I thought, you know what, we should really bring that forward now. And so I've identified nature. And sorry, keep in mind that these are just arbitrary lists. Like there might be what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 under transportation. There may only be 8, or there may be 14. I'll let you decide how many you want to identify. But with nature, I could think of at least 1, 2, 3, 4, 5, 6, or 7. And I thought, yeah, if I had to identify nature assets, natural assets based on what is identified in the Metropolis narrative, those are the ones I would focus on. So I'm curious to see what you come up with. And that would just mean then saying, okay, is there an interaction between a road surface and high temperature or low temperature or freeze-thaw cycles or heavy rain? And quite frankly, the road surface for the bridge, probably for most of these, except for sea level rise, which is unlikely to have an impact on the road surface per se. Um, and so you really just have to insert not necessarily a yes or no, but for a yes and no, just put in an X wherever you think there is an interaction, and you leave it blank if you don't think that there is an interaction. So I'll see what you can do with that. And then basically use the same template to come up with your consequence table. And in this case, I think it's important to be able to differentiate, if you wish, going that extra mile of saying if you're struggling with trying to figure out what is a low, what is a medium, and what is a high, at least within each of those categories, then I would suggest instead of giving me a number, you give me a letter, L for low, M for medium, and H for high. And at least give me that. So all I'm asking you is to come up with 3 levels of consequence, low, medium, and high. But ideally, and I'll probably give you the benefit of the doubt or a higher grade, depending upon how accurate you are. At least give me the 1 to 7 scoring. So with that, going back over the case study again, there are examples for you to draw from, things to help you in terms of figuring out what assets you should be looking at and how they may or may not interact with the different climate hazards. So table 1, table 2, and table 2 or A and 2B for transportation and energy. All that information is there. So this is not really difficult in terms of having you make anything up. It's just being a good detective, a critical thinker, go through the assignment. The information is there. Answer the questions. So as I had said, the marking scheme will be 10 marks for all 3 sections. And I'm really hoping that you'll be able to demonstrate your own thinking and analysis rather than relying on AI or anything else in terms of providing your answers. Okay, so there you go. I hope that provides you with some clarity on what it is that we're trying to achieve, and that you're able to do the assignment straightforward. And at this point, I'm really pushing for you to submit it on the 13th. If you are in dire straits and you do so at your peril, I'll keep the date open for submitting until the following Friday. So the 20th, which is the end of your reading week. So if you want to blow your reading week by still working on the assignment, well, you can do so without penalty. But I would really like to close it off so that I can get marking and get these done and back to you in due course when you come back to class the following Tuesday. And if I don't have them back the following Tuesday, then none of us are going to be happy. And I'll be looking at marking for that following week as well. Okay. Don't hesitate to reach out if you have any questions. Otherwise, there it is for you, and hopefully that'll give you enough guidance in order to do the assignment. Thanks, and have fun with it.